Okay, first thing you have to do is draw a free body diagram. Here's Mrs. Nagel. I look a little square today. I have a mass of 68 kilograms. I want to know what the force of gravity is, the experience on the chair. Force of gravity, if I look at my reference table, force of gravity is right here. It's in a very lame format. So I multiply each side by mass. Force of gravity equals mass times gravity. Mass times gravity. So when I draw my free body diagram, I have the force of gravity going down, also known as weight. How do I know that? Force of gravity, Fg, is also known as weight. And then I multiply those together. 68 kilograms times 9.8 meters per second squared. And it's pointing down, so just make sure your final answer is negative. All right, now what's the force normal? That's the normal force that exists that normal people never think about. It's always around us. Normal force is the force of gravity. They're balanced. All right, I'm going to show you this equation. Force net, the two forces on the object, which is me, is it accelerating? It's not accelerating. I'm standing still, so that's all zero. So force net equals zero with the two forces. Force normal minus force of gravity. Watch that. I want double negative. I just want to make sure I'm subtracting. 1 point's up, 1 point's down. Equals zero. Now if I want to solve for one or the other, I add force of gravity on both sides. And then I'm left with force normal equals the force of gravity. So this answer, when you multiply that together, my calculator, 68 times 9.8 equals 664.4 newtons, and it's going down. It's pointing down. And then force normal, it's the same. But this time it points up. So it's positive 66.4 newtons up. Oh, I weigh a lot. Yeah, newtons, yeah, okay. All right, now wonderful student standing up. Student has the mass. What's the weight? We're going to draw the picture. Force of gravity. Force normal. Force of gravity is mg. 50 kilograms times 9.8. It's about 500. You do the math. About 500. Yeah, multiplying by 10. Force normal is the force of gravity. So whatever you get here, these two are the same. The force of gravity, also known as weight, is going to be negative. What is it? I guess I'll do it. 50 times 9.8. Damn. 490. Negative 490 newtons going down. Force normal. 490 newtons going up. Bam. Next one. Charming physics student. I don't even know what I just hit. Darn it. I don't even know where I am. Here. Ah, good. Hit a button. So, charming physics student hangs a mass. I got to draw a free body diagram. So, hangs a mass on a spring. Spring constant is, that's your K. 147 Newton meters. Notice the unit, Newton divided by meter. When the mass is hung on the spring stretches 2 centimeters. So here's your force of spring, it's an S. And here's your force of gravity. Technically there's a spring here. I'll make it in red. It was kind of like stretching. That's a spring. Da, 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 da. Force of gravity. Force of the spring. They're balanced to each other. So what is the force of the spring? Well, you got to know what the force of the spring equation is. Force of gravity is mg. Force of the spring constant. Look on your physics reference table. Bam, right here. In a nice, easy format. K is the spring constant. X is either the compression or the stretch, or elongation or the stretch. Okay. All right. So then I write Kx, the force on the spring, the force of the spring. Looking for this. It's going to be K, 147 147 newtons times the stretch, 2 centimeters. I can't use this. This is a Newton meter. Oof, goodness gracious. I'm trying to hurry. 147 Newton meters. That's my K. Now I'm multiplying by my X. How do I have to get 2 centimeters into meters? Because I have to have a meter unit. Every number can be written over 1. My ratio is 1 meter to 100 centimeters. Multiply the numerators together, I get 2. Multiply the denominators, I get 100. The centimeters cancel out. My unit is a meter, which is 0.02 meters. Multiply those together. You're going to get 147 times 0.02, 2.94, and the final is a newton. Now, what's the force of gravity? Force of gravity is mass, which is 0.3 kilograms times negative 9.8 meters per second squared. We know it's pointing down, but just, putting it down. So then I multiply 0.3 times 9.8. Oh, wow, it's the same. It's not moving, it's balanced. So force net equals 0. Force of the spring plus a negative force of gravity. Does it equal 0? Sure bet. 294 minus 294, same thing. Yep. Right, now what happens? Do the same thing, but something else is going on this time. Here's my force of gravity, mg. Here's my force of my spring, kx. mg is, when the mass is on the spring, the mass is 0.5 kilograms times 9.8. That unit will be a newton. The spring, 147 Newton meters times the stretch, 0.03 meters, divided, brought that over to a meter. What are my two numbers? 147 times, can't see, 147 times 0.03, 44.41 newtons. What's the bottom number? 0.5 times 9.8 is 4.9 newtons. So my force net, is there an acceleration? Yeah, for one few seconds it's accelerating. So you have the force of the spring pulls up, plus a negative force of the gravity pulls down. What's going on? Force of the spring, 4.41 newtons plus a negative 4.9 mass times acceleration. Add those two numbers up. That's a negative. So 4.41 minus, because I'm going down, subtracting the unit, 4.9. It's accelerating by 4.9 newtons. If I wanted to find my acceleration, I know my mass. I can plug in my mass and find my acceleration of the spring for that second. So explain what's happening. Falling, accelerating down.
Today is just not my word.